In this section, we'll dive into the actual analysis of our post structures. In this analysis, we're going to focus on the concentrated live load only. The axial load is very small relative to the axial capacity of the post. And, in addition, if you consider a wind load running through the same process specified by ASC 7 in the wind load section, you'll find that the wind load is pretty negligible, somewhere between 1 and 10 pounds, depending how you define the shape factor for the fence. Now we would start with the tributary width, which is a maximum of 200 centimeters for each post. However, because, like I said, we're taking exception 1, we only need to apply that 200 pound or 0.89 kilonewton load at the worst place, which is going to be the top of the fence post. So our maximum moment is going to be PL, which is around 0.98 kilonewton meters. We'll find the actual capacity of the column using the AISC specifications in Chapter F for flexure. So you may remember from the decking section where we check the crossbeams. We'll first check for compactness in table B4.1b for flexural members. And in this case, the limiting lambda p value for round HSS members, or pipes, is 0.07 square root of E over Fy. Remember that Fy in this case is 50 KSI for the HSS pipe, so we get a value of 40.6. Reading from table 1-13, where we have our dimensions for our HSS pipe, we can read directly off that a D over T ratio of 14.1, and this tells us, because it's less than 40.6, we have a compact section. So once again, our member will reach its full yield strength, so we can check Mn equals Mp, which is our Fyz, which is less than or equal to 1.6 Sfy. And we'll use our reported factor of safety once again of 1.67 for the allowable stress design. When we run the numbers for our F2E detail, we get that in this case, different than decking, our Fyz value will govern, and that will be 2.94 kilonewton meters. This is written out incorrectly, kilonewton meters. In that case, we can check that our required moment is going to be 2.94 divided by our factor of safety, which is going to equal 1.76. And because this is greater than our 0.98 kilonewton meter value, our fence post will pass this flexural check.